All right, so I wanted to go over the practice final. So I wanted to show you first the format. So you have three different parts. You have the first part, and there are 40 multiple choice questions. And then there's part two, which everyone's going to have to do. And I think there are 3 questions for part two. Okay, those are the required questions. Okay. And then part 3, you have to choose 7 of the 12 problems. So there are 7 problems. Each problem is usually 1 page. Sometimes it runs over to 2 pages. Okay, so 12 problems there. You have to choose 7 out of 12 for me to grade. And so that's what's here on the first page of the exam. And so here you have to tell me which ones in part 3 that you want me to grade. Don't just expect me to grade every one of them. If you forget to note which ones you want me to grade, I will grade the first 7. Okay. If you want me to grade a bonus question, that will be the 8th problem. Just write bonus next to the number. Okay, and then I'll grade that as well. So again, if you don't tell me which questions to grade, I will grade the first 7. Okay, so make sure you let me know which ones out of those 12, which 7 you want me to grade, and then the 8th one will be the bonus. All right, so let's go through the practice tests. So the first question here is a multiple choice question. They're asking you to calculate the molecular mass of methyl. And so here we have the formula C10H20O. And so here I'm going to multiply the number of carbon atoms 10 times its average atomic mass, which is roughly 12. So that's 120. Do the same process for hydrogen. There's 20 hydrogen atoms times its average atomic mass of 1. So 20 times 1 is 20. And then there's 1 oxygen atom, 1 times its average atomic mass, which is roughly 16. 1 times 16 is 16. You add these together to get 156 atomic mass units. So that's your answer for number 1. Number 2, it says when nitrogen monoxide reacts with oxygen, nitrogen dioxide, and 57.0 kilojoules of heat are produced. This reaction is. Now, you may be thinking it's endothermic because it doesn't say that it's negative. But the negative there just indicates that heat is being released, and it says so in the form of words here. It says 57.0 kilojoules of heat are produced. So when heat is produced as a product, we know that indicates that the reaction is an exothermic reaction. Number 3, it says which precipitate forms from mixing copper 2 sulfate and sodium sulfate. So here we're going to have to balance out the equation and predict the products. So here we have copper sulfate and sodium sulfate. So that's going to produce copper 2 sulfate and sodium sulfate. Again, you get the same products as you did reactants because the anions are the same. So obviously you don't have, because copper sulfate and sodium sulfate are going to be aqueous, so you don't have a precipitate, and so your answer for that one should be C, no precipitate forms. For number 4, it says which one of the following is most likely to be an ionic compound. So we know ionic compounds are formed between a metal and a nonmetal. So if you look at it, your answer choices here, the only answer choice that has a metal in it is B. Calcium is a metal, chlorine is a nonmetal. So your answer should be calcium chloride. All right, part 5 here, question 5. You're having to basically get the decimal form of 1 over 23. And so I wrote out what it gives you in the calculator. You're going to have to write it as a decimal to 4 significant figures. So Here are 4 significant figures here, 0.0434, and then you're rounding the 7 to 8. So your answer should be 0.04348. So E is your answer there. All right, number 6. So for number 6, it says a 21.8 gram sample of water contains how many water molecules? So you're starting out with 21.8 grams of water, converting grams of water to moles of water using molar mass of water. You have to calculate that out. And so you calculate it out the same way we did the first problem here, multiplying the number of atoms times its average atomic mass, rounded off to the nearest whole number. Now, it's not always the case, but with hydrogen, it's really close to 1, and oxygen is really close to 16, so here we have 2 whole numbers. We add them together to get 18 grams per mole for the molar mass of water. Okay, and then we have to convert moles to molecules. That's the question. How many water molecules does the sample have? And so you have to use Avogadro's number. And so when you do the math here, you get 7.29 times 10 to the 23rd molecules of water. Number 7 says according to the reaction here, and seems like there's a reaction. It's missing an arrow. So here we go. The arrow should be somewhere here. All right. You're starting out with 0.840 moles of ammonia. Okay. And it's asking how many moles of water will be formed. So we're starting out with 0.840 moles of ammonia. And so we use our molar ratio. So every 4 moles of ammonia, we can produce 6 moles of water. Okay, so when we do the math here, we get 1.26 moles of water for our answer. All right, number 8, the mass of 1.21 times 10 to the 20th atoms of sulfur is what? So here we have a very large number of atoms of sulfur. We convert atoms to moles using Avogadro's number. Okay, and then we convert moles to grams using molar mass of sulfur. Okay, we look that up on the periodic table. Look that up. Sulfur is roughly 32 grams per mole. Okay, and then we do the math there, and we get in our calculator we're getting grams, right? Because our units here are grams per mole. So moles cancels out, atoms cancels out. You're left with grams of sulfur, and that's not an answer choice on your in your calculator. So you're going to have to move it. It's going to be 0.00644, and so you move the decimal place over 1, 2, 3 places to the right to get milligrams. So in your calculator, you get 0.00644 grams, and so when you multiply that by 1,000, you get 6.44 grams, or milligrams, because we know 1,000 milligrams is equal to 1 gram. So when we multiply by 1,000, we get the 6.44 milligrams. All right. Number 9, what is the formula for the ionic compound formed by magnesium and iodine? So magnesium has a positive 2 charge because it's in group 2, and iodine has a negative 1 charge because it's a halogen. And so its formula has to add up to 0. If we have plus 2 minus 1, we need 2 iodines. So it's going to be MgI2. So D is your answer there. So that's the formula for the reaction between magnesium and iodine. Number 10, which of the following is a D block element? So if you look in the D block, this is the D block here, this light pink. Okay, so our answer choices are californium, which is down here. So that's not D block. Carbon, which is right here, that's in the P block. Calcium, which is right here, that's the S block. Chromium, is right here. So anything in this light pink area is a D block element. So chromium is your answer. Cesium is right here. It's a S block. So your answer should have been D, chromium. Number 11, which of the following numbers represents 7,500,000? So you can see my little blips here because I had to count how many times I moved the decimal place over to the left, and that counted 6 times. So the number in scientific notation should be 7.5 times 10 to the 6th power, positive 6. Number 12, given the number of protons, electrons, and neutrons in one atom of nickel 62. So my first thing to do would be to look up the element for nickel on the periodic table to figure out the number of protons it should have. It gave me the atomic mass. Mass number can vary between atoms of the same element, but proton number never changes. Okay, so I need to look it up, how many protons nickel has by looking at the atomic number. So when I look for nickel right here, oh, I didn't want to see that. I just wanted to see it. Blow up there. There it is. Okay, so when I look at nickel, I can see it has atomic number 28. Okay, so that means it has 28 protons. All right, so nickel has 28 protons. And so it has its atomic mass is 62. Its atomic mass tells me the number of protons plus the number of neutrons. So I have to take the atomic mass subtracted by the atomic number to find the number of neutrons. So 62 minus 28 is 34. So nickel has 28 protons, 34 neutrons. And because it didn't say it was an ion, we also assume it has the same number of electrons as protons, which is 28. So your answer should be, if you get your answer choices, 28 protons, 28 electrons, and 34 neutrons. So B should have been your answer. All right, for number 13, it says calculate the frequency of visible light having a wavelength of 686 nanometers. So I showed you how to write nanometers in terms of meters. You just rewrite it because you're multiplying times 1 times 10 to the negative 9th meter. So you just write it as 686 times 10 to the negative 9th meters. You always have to remember to do that conversion because the units for speed of light is in meters per second. Okay, so if you're given nanometers, you have to convert it to meters. So just by rewriting that, you've sort of converted it in a way. All right, so if you're trying to find frequency, we know frequency is equal to the speed of light over the wavelength. So the speed of light is a constant, 3 times 10 to the 8th meters per second, divided by the wavelength, 686 times 10 to the negative 9th meters. Okay, do the division there to get the frequency of 4.37 times 10 to the 14th hertz. All right, number 14, here we have a question. What is the ground state electron configuration of calcium? So we have to first find calcium on our periodic table here. An easy way to go through this here is look at where it ends. Okay, so here I have calcium, so that's 4s2 should be the last part of it. And the only one that ends in 4s2 is answer choice C, which is the answer. But if you go through all of this, you can see it's going to be 1s2, 2s2, 2p6, 3s2, 3p6, and then 4s2. Get you to calcium. Here it was a long way, it wasn't the abbreviated way, it was starting with hydrogen and not starting with the nearest noble gas. All right, so you should be familiar with both ways, okay, when you're looking at electron configuration, because your answer choices could be using the abbreviated form or the long form when you're starting out with hydrogen, having to go all the way through all of the, showing all the electrons and their energy levels in subshells. All right, so number 15 here said predict the molecular geometry of the SO2 molecule. And so the first thing you need to do is to draw out the Lewis dot structure. So that's what I did here. Notice there are 8 electrons around each element here. In order to do that, you have to make double bonds between sulfur and oxygen, okay, on both sides. And then sulfur has 6 electrons, so it ends up having a lone pair there. All right, so your book described 2 different ways of looking at, you have molecular geometry and you have electron pair geometry, which is a bit different. It's sort of like the parent with no lone pairs. And so if we were to look at this electron pair geometry, there's 3 electron pairs here, okay? And so that would have a trigonal planar electron pair geometry. But it has 1 lone pair, okay? So its molecular geometry is going to be different from its electron pair geometry. And because it has the 1 lone pair, it is going to be bent. Now I wanted to show you that from your textbook. Here we have 3 electron pairs, okay? But in this case, so this is our electron pair geometry for like the parent, but our molecular geometry here is going to be different because it has 1 lone pair. So its geometry should be, molecular geometry should be bent. Okay. All right, so let's see the answer circled there. Number 16, according to VSEPR theory, the molecular geometry of CO2 is what? So again, doing the same process, writing out the Lewis dot structure for CO2. Notice that carbon has to have 2 double bonds on both sides with oxygen in order to have 8 electrons around each atom of this structure. So you have here, in this case, you have 2 electron pairs. You have no lone pairs. So in this case, your molecular geometry should be bent. I'm sorry, not bent, linear, because you only have 2. So number 17 is kind of a similar question. It's dealing with Lewis dot structures. Here we have a structure where it's called a fluoroberylate ion. It's asking what the formal charge is on the beryllium atom. Okay, so we're having to draw out the structure. And so this structure here has a -2 charge. Okay, so if you look up beryllium on the periodic table, you notice it's in group 2. Okay, so it should have 2 valence electrons. Okay, and then fluorine, group 17, has 7. All right, so when we're drawing out the structure, we'll see real quickly why you have to have the -2 overall charge on this structure. And that's because here, beryllium is going to have 1 single covalent bond for every fluorine atom. There's 4 fluorine atoms. And so instead of having just 2 valence electrons, it has to have 2 extra electrons in order to make the covalent bonds with each of the 4 fluorine atoms. And so the question is, what is the formal charge on the beryllium atom? Well, for the fluorines, they're all zeros because there's 6 loose electrons here and there's 1 involved in a covalent bond. And that's the case for every fluorine atom. But with the beryllium, which is what the question was, here we normally would have 2, but we have 2 extra. So that means that it would have a -2 formal charge on the beryllium atom. A reaction where the products are higher in energy than the reactants is an example of what? So we know when the product energy is higher than the reactants, we know that's an example of an endothermic process. Energy has gone into the system, more energy has moved into the system than has left. And so that's why the surroundings get cold, because the energy transfer is towards the system.